Hello, my name is Imani Vincent, and this is my remote sensing final project. The title of my project is Evaluating Vegetation Dynamics for Stormwater Impacts, a Normalized Difference Vegetation Index and Land Cover Change Analysis of Gwinnett County from 2013 to 2023. I did an analysis of land cover change and NDVI in Gwinnett County to analyze vegetation dynamics as a potential indicator for stormwater impacts, which also leads into my capstone graduate research. Here is my table of contents. So first I'm going to go through the introduction, then methods, as well as results and discussion, and then lastly I would talk about my conclusion and future work. So again, my study area is Gwinnett County, and the reason I picked this area is because I am a Gwinnett native, and if you didn't know, the data is so available in Gwinnett County, which is great for me as a researcher. And Gwinnett is in a weird gray area where it's becoming more urbanized. I went to school in North Georgia, and when I would come back home during the summers, I would notice more and more built environment. There's always construction going on, which means population growth, urban sprawl, and congestion, of course, and land cover change. So I am a GIS analyst intern for the ARC, Atlanta Regional Commission, and one of my jobs is to track stormwater as well as map green spaces. So I've definitely noticed that as more and more cities in the metropolitan Georgia area urbanize, including cities in Gwinnett, there's an increase for mitigation such as green spaces. This is the reason why I wanted to analyze vegetation and dynamics in Gwinnett. As I've researched, I noticed that the most common green spaces are located in parks, greenway trails, as well as conservation areas, which helped me when analyzing my NDVI analysis. Here are my research questions. The first one is, how has vegetation density as indicated by NDVI and land cover analysis values changed in Gwinnett County from 2013 and 2023? The second one is there a correlation between areas of increase in NDVI and known stormwater mitigation hotspots? And lastly, how has land cover change and vegetation trends influence stormwater impacts in Gwinnett County? Stormwater is water from rain events that can stay on the surface and run off into water bodies. Stormwater runoff carries pollutants from urban landscapes into streams, causing them to become impaired and manifest as something called stormwater failure, which is just nuisance flooding and stream bank erosion. As a result of growth and development, when a county has been subjected to these stormwater impacts, there is a need for mitigation. Let me go back, sorry. I included these research questions to kind of help hone in on my remote sensing topic, just to stay on track, but I'll have you know that if these research questions cannot fully be answered through this preliminary study, I will use it as a summary of data that I will use in further research, which will be conducted in the near future. So now, here is my methodology. Firstly, I performed data collection. Then I went through image processing, layer stacking, subsetting. Then I performed my land cover and NDVI analyses. And then I evaluated this work for future work. So for data collection, this figure is of satellite imagery of Gwinnett County from 2013 and 2023. The images covered Georgia metropolitan area and were downloaded from USGS Earth Explorer. The first imagery on your left is a Landsat 8 image collected November 2013. And the one on the right is also a Landsat 8 image collected November of 2023. Both images are 10 years apart and were downloaded in a GeoTIFF format. The images were acquired during the day and have 0 cloud cover. So then a shapefile of the Gwinnett County boundary was downloaded from Gwinnett Open Data Portal in order to subset the land images, and then pre-processing was conducted. And these techniques were done in NV and ArcGIS Pro. And since both images acquired contained no cloud cover, atmospheric correction was not necessary. Therefore, only layer stacking and other corrections were applied. For the layer stacking, multispectral bands in each of the georeferenced Landsat images that were collected went through a process to reproject the images with the right coordinate system to match the shapefile, which made subsetting the images way easier. And this figure kind of shows the layer stacking from the 2 different years. The next step was to subset by the ROI. So again, the ROI was the shapefile of Gwinnett County boundary, like I said before. So then the multispectral bands, Landsat 8 images were resized with the ROI to occupy Gwinnett County. And then using the mass feature is how I got these 2 figures. And then after I was able to perform the analysis on the area of interest that I wanted. And these 2 figures again show the true color imagery of Gwinnett County collected in their respective years. Next, I performed a land cover classifications. I used unsupervised classifications, and here are my specific classes. There's water, which included water bodies, rivers, lakes, ponds, etc. Then next is vegetation, so high density vegetation, which is represented by forest, and then low density vegetation, which is represented by grassland. Then urban areas, which include the built environment. And then lastly, bare ground, which is just areas not occupied by plant life. Instead of combining the vegetation classes, I opted to differentiate between the 2 due to my aim in observing green spaces and existing plant life as an indicator for stormwater impacts. Also, a change detection analysis was performed as well to see the differences. So here are the results of the land cover classifications. On the left, we're observing these figures. There's an increase in urban areas, especially around the interstate, which is also due to increased built environment. And a class summary statistics were also calculated for both years. And here they are. I'm kind of in the way, but there was a reduction in the land cover class bare ground, going from 1.23% to 0.81% in 2023. This is probably due to the fact that previously exposed areas are now developed. Water was stable all the way through, which only increasing a little bit from 5.45% to 5.52% in 2023. So there's minimal change over the 10-year period, and this is due to Gwinnett's consistent policies in land cover, which you can actually read from their 2045 Unified Plan on the Gwinnett County website. And this is their desire to grow in all ways, including land cover. So for the high density vegetation, there was an increase, and it went from 40.74% to 45.09% in 2023. And then the low density was 32.7%, and then it went up to 35.2%. The increased growth with the high density suggests reforestation efforts, improved land management, and even just natural growth of vegetation. You can see this represented by organizations such as Gwinnett Clean and Beautiful, which help with littering, beautification, and other regreening efforts. So the high density vegetation increase is definitely evident of this work, but that could also be just due to natural growth as well. And there was, of course, an increase in urban areas from 2013 to 2023. The values increased from 13.24% all the way up to 19.78% in 2023. This is, of course, due to urban sprawl in Gwinnett County, which has evidence from the land cover analysis. And then I also performed a change detection analysis. Here are the 5 classes before I subsetted them by the ROI. I mainly wanted to highlight 2 of them, but before I get started, I wanted to include a refresher. So change detection is best described as being able to distinguish of where change has took place, basically. So by observing these figures, any black pixels experience no change for that given class, and the pixels that have color represent the given class in 2013, but the classification has probably changed in 2023. So then that means that the colorful pixels correspond to the new tree class. So using this tool, I was able to evaluate the decadal change in Gwinnett County from 2013 to 2023, which is way easier than just visual inspection. So this figure represents bare ground in 2013 compared to the other land cover types. But again, I'm comparing 2013 to 2023. So the black area represents areas where bare ground wasn't there. And then it also represents bare ground in 2013, and then it pretty much remains similar to 2023. There's not much going on here. Then one that I wanted to highlight is vegetation. And this is high density vegetation, to be more specific. There was significant change, and you can see by all the green color all around. So going back to this image, there's minimal change in a bare ground compared to the other classes. And then there was a lot of change in the vegetation. And then going back to the main image, so again, there was minimal change in water and bare ground. There was moderate change in vegetation, while urban areas exhibited the most change. You can see from these 2 tables I'm about to show you. So here's the first table. So you can see that urbanization definitely increased. And then here's the second table. So the last analysis that I conducted includes a normalized difference vegetation index of Gwinnett between the 2 years, just to add further evidence for my results. And on one hand, the NDVI imagery shows similar results to the land cover classification, but NDVI is helpful in letting me know where the healthiest vegetation is. In these figures, the highlighted areas in orange have the higher vegetation, and the areas in green have the lower vegetated areas, which we can see here. So this furthers my claim that Gwinnett is continuously and rapidly urbanizing, which can catapult positive development, but can also put the environment at risk, especially when Gwinnett is susceptible to stormwater impacts due to the urbanization, which again, stormwater impacts such as stormwater failure is nuisance flooding and stream bank erosions. So as Gwinnett becomes more residential, there is an increase in urbanization, which then causes the ecosystem to suffer. So we need strategies for sustainable development for natural resources and our future. So here is my future work portion. I want to mention that this research will be further developed into a capstone project. And to reiterate, my aim is to understand vegetation dynamics in Gwinnett County, but more specifically with the NDVI index and land cover classification values to be used as an indicator for stormwater impacts And I will do this with a geospatial analysis of stormwater failure points and vegetation dynamics. As you can see from this figure, this is stormwater failure in Gwinnett County that I made at work, and the blue flags represent flooding and the red flags represent sinkholes. And I'm still continuously tracking the stormwater, so then I will have better results in the future. But lastly, I wanted to mention some limitations of this project, which the drawbacks when using NDVI in relation to urban trends is a little difficult, and also using unsupervised classification versus supervised is another drawback because there's room for error with no training data. And then lastly, future work is a limitation because I'm using this project as a way to hone my remote sensing skills, and therefore I'm using this as a data summary for my capstone project. So again, this is Imani Vincent. Thank you for listening.